This is a quick walkthrough of the algebra of market equilibriums. If you recall, we talked about equilibrium as being the point where demand and supply intersect, specifically market equilibrium, right? This point where demand and supply intersect, our market equilibrium, has two components to it. There is vertically a price component, and horizontally there's a quantity component, and we refer to those as P star and Q star, right? And we've defined these as P star as being the price, where the quantity demanded is equal to the quantity supplied, and Q star is the quantity that corresponds to that price. But what if we actually have market equations and we wanted to solve this very simple little system of equation to find those values of P star and Q star, to figure out what are the equilibrium values. So the first thing we want to do is kind of get a sense of what the market looks like, right? So if we've got, this is our demand equation, right? And it's similar, or it's familiar y equals mx plus b format, where we're measuring price on the vertical axis, but we also know it looks like our vertical intercept is 50. And with a little bit of algebra, I could solve for QD when I set price equal to 0, and I could find out that my horizontal intercept on that demand curve is 500. If I look at my supply equation, it looks like the only relevant piece of information right now for me is that it has a vertical intercept of 10. So I know a couple of different things, right? If I put those pieces of information into my graph, I know that my price, my P star, the value that I'm going to be looking for, I'm hoping for it to be somewhere between 10 and 50. And Q star, I'm hoping for it to be somewhere between 0 and 500. Now, one thing that I did here is I have these two equations, but if you notice, the slope is not the same, right? It actually looks like the slope of the supply curve should be a little bit more steep, but it doesn't look like it's a big dramatic difference on my graph. It should be that maybe the supply curve is a little bit more steep, so I'm thinking maybe my price is going to be a little bit more north of what I was expecting, and my quantity might be a little bit less than what I was expecting. Still between 10 and 50 and 0 and 500, but I got a little bit of a sense of what's going on here. So if we want to solve this very little system of equation, there's a couple of different ways to do it. The easiest way is to think about what is our market equilibrium condition. It's when supply is equal to demand. It's the price such that the quantity demanded is equal to the quantity supplied. I can take these two equations, the right-hand side of both equations, and I can set those two right sides equal to each other. So again, just to make sure we all see what's going on, we've got that right-hand side equal to that right-hand side, and then just simply solving for Q. One step before we solve for Q, our market equilibrium condition says that it's the price such that the quantity demanded is equal to the quantity supplied, and our equilibrium quantity, we just call that Q star. It represents both the number of units that consumers want to buy and the number of units that producers want to sell. Those quantities are the same at our equilibrium. So I don't need to write QD and QS anymore. Rather, I can just call them Q, because at equilibrium, they are the same value of Q. So setting the two sides equal to each other, dropping the superscripts, and then again, just doing a little bit of algebra manipulation, reduce 10 from the left-hand side, move this over to the right-hand side, should be 40 equals 0.3 Q, and then divide through by 0.3, double check my math, and what we end up with is having a Q star of 133.33. I'm absolutely okay having two decimal places on this Q. You may be thinking, oh my gosh, if Q is something like a car or a textbook, is it really possible to have 1/3 of a textbook? Well, a lot of the times when we measure quantities, we're measuring them in thousands, so the decimal then does make sense, even if we can't necessarily break a car in thirds and say that it's a useful thing. So we've got our value of Q star that we calculated. Does that seem reasonable based on what we know about our graph? Yeah, that number is somewhere between 0 and 500, and again, we said because of the slope difference that we think it would be actually a little bit lower than what we were initially expecting. So if we know Q by setting the two right-hand sides equal to each other and solving for Q, you can take that value of Q, put them back into either the demand or the supply equation to get the value of P star. Actually, can't we do both if we've got the time to do it and make sure that our answers match up? taking this value of Q star and putting it back into my demand equation in place of QD gets me to a price, a P star, an equilibrium price of 36.67. Or alternatively, taking that quantity, 133, that equilibrium quantity, and putting it into the supply equation in place of QS also gets me 36.67. That's great, right? I want these two to match up because that tells me that my algebra is probably correct. Not always correct, but probably correct. So again, we've got our two values that we've solved for. Our Q star is this value over here, and our P star is this value right here. That is a quick little introduction to the